Hi, today is day 25, I believe, and today's episode is brought to you by the Greek letter sigma. That is a lowercase sigma. Uppercase sigmas, of course, they look like the letter E and they are used to represent summation. Lowercase sigmas are usually used to represent stress. If you have something like this rubber band in tension, and you take the tension force and you divide by, well, whatever the cross-sectional area of the rubber band is, then you have the stress inside the rubber band. You have calculated sigma, very popular amongst engineers. Anyway, what we want to look at today, as you can see, the electric field due to a point charge. We learned how to calculate the forces between a couple of point charges yesterday, but today we want to learn how to calculate the electric field due to a point charge. So first of all, a little bit of review. Remember that gravitational field has units, newtons per kilogram. Okay, any force field is going to have units of force per something or other. Well, electric field is going to be newtons per unit charge, either newtons per coulomb or newtons per elementary charge. Most commonly. Sometimes you'll see something weird like newtons per millicoulomb or whatever. Remember the definition of electric field. It kind of parallels the definition of gravitational field. Gravitational field is the force per unit mass, while electric field is the electric force on a unit of positive charge. Why positive? Well, basically because a bunch of people agreed that if you're talking about electric field, that's the way it's going to be. If you're going to talk about electric field, you got to talk about the electric force on a unit of positive charge. Gravitational field. Another way to define gravitational field is the region surrounding a mass where another mass feels a gravitational force. Well, here is the equivalent for an electric field, the region surrounding a charge where another charge feels an electric force. All right, so how do you calculate electric field due to a point charge? Well, that's what we want to do right here. We want to find the electric field at a distance r from a charge q. Okay, so here we are. There's our charge big Q, and let's suppose we're some distance r from it, and we plop down a charge little q. Okay. What is the electric field going to be? Right here, where this charge little q is. Okay. Well, you have to remember that these two charges, they're either going to exert a force of traction or repulsion on each other. Doesn't really matter which. Let's suppose that big Q is trying to repel little q away. So big Q exerts an electrostatic force or an electric force F on little q, just like that. Okay. And you remember, of course, how to calculate that force. That's Coulomb's law. Okay. That force, how to calculate it is right here. It's the force between two charges. Well, it's going to be equal to K times one charge times the other charge over the distance between them, all squared. Okay. Now, let's go back and review a little again. Remember, electric field. It is what? Force per unit charge. So how do you calculate electric field? Well, just like the units say, you take your force and you divide by your charge. How do you calculate your electric field? Well, it's going to be the electric force divided by the charge. So if you arrange this equation ever so slightly, if you take the Q up to the other side, okay, well, then you're left with F is equal to EQ. So this force, it's going to equal to the electric field that this charge is in times this charge. Okay, so let's make that substitution. Okay, this force, F, is equal to EQ. Okay, and look, there we make the substitution. F is equal to EQ. The rest of the equation stays the same, and I'm pretty sure you know what's coming next. Okay, the Q's cancel, or the little q's cancel. You got one on each side, and there's your final equation. The electric field is equal to K times big Q over R squared. If you want to calculate the electric field due to a point charge, there it is right there. And the thing to remember, if you're using this formula, big Q, that is the charge creating the field, not the charge in the field, it is a charge creating the field. We'll come right back and do a little example using this. All right, here's the example we want to take a look at. We have three charges here. Q1 is equal to negative 10 elementary charges. Remember, an elementary charge is a charge on a proton. Q2, positive 10 elementary charges. Q3, negative 10 elementary charges. And these charges are arranged in a nice, neat triangle. This side and this side are both the same, 1.41 centimeters. We've got a nice, convenient right angle there. And what we want to figure out is find E at the midway point between Q1 and Q3. So the midway point between Q1 and Q3, we'll call it point P. And it's probably right about there. And let's see if we can figure out what the electric field is right there. Well, I'm pretty sure most people are going to agree that the electric field at point P is going to be equal to the electric field at P caused by charge number 1 plus the electric field at point P caused by charge number 2 plus the electric field at point P caused by charge number 3. Okay, so the electric field at P, the total electric field at P is the sum of the electric fields contributed by all the charges. And what can we figure out about these electric fields? Well, remember, if you're dealing with electric field, you're talking about the force on a unit of positive charge. So let's pretend that right at point P, there is a positive charge there. Right where point P is, there's a positive charge there. Okay, now take a close look. What's Q1, which is negative, going to do to that positive charge? Well, it's going to pull it that way. Q3, it's also negative. It's going to take a positive charge here and pull it that way. Q1 and Q3 are pulling a positive charge right in the middle there in opposite directions, and they're going to be pulling with the exact same force. Because let's face it, this is the midway point between Q1 and Q3, so the two distances are equal, and the two charges are equal. So E1 and E3, these two electric fields, they're going to cancel each other out. Don't have to worry about that. So that's kind of nice. The electric field at P is equal to the electric field caused by charge number 2. Let's see if we can figure that out. Well, the electric field at P caused by charge number 2, that's the electric field that's being caused by a point charge. So it's going to be equal to K times the charge causing the electric field over the distance squared. And of course, we want the distance between point P and charge number 2. Okay, so what is that distance between point P and charge number 2? I'm pretty sure we can figure that out. Take a look. That's a right angle triangle. These two sides are the same. That means this is a 45-degree angle, and of course there's another 45-degree angle over there. If you draw perpendicular up from the midpoint of this side, well, you're going to land smack dab on the vertex opposite. Okay. And basically, you've taken this 90-degree angle and you've cut it in half. So this is going to be 45 degrees and this is going to be 45 degrees. And of course, this is a right angle. Okay, 45, 45, 90 degree triangle. We want to figure out this side, so you can use that, or pardon me, you can figure that out using a little bit of trig. Or if you like, you can do it super fast. If you remember that in a 45, 45, 90 degree triangle, the sides are always in the ratio 1 to 1 to the root of 2. And the root of 2 just happens to be equal to 1.41 centimeters. So this side is going to be 1 centimeter. This side is going to be 1 centimeter. And this side is going to be the root of 2 centimeters, which is 1.41 centimeters. Okay, we're ready to substitute in now. K, remember there's two possible values of K. There's the big one and the little one. Well, we're not using coulombs, the big unit of charge. We're using elementary charges, the little unit of charge. So we want to use the little value for K, which is 2.3 times 10 to the minus 28. Okay, so there's K. Now we have to substitute in Q2, the charge causing the electric field. That's 10 elementary charges. And then we get then we have to divide by the distance squared. And remember, convert the distance to meters. So 1 centimeter, that's 0.01 meters. Yes, square it. And you grind this through your calculator, and I believe you get, oh boy, there we go, 2.3 times 10 to the minus 23. We need units. Okay, it's an electric field. Any field is going to be force per unit something or other. So this is going to be newtons per elementary charge. We measure our charges in elementary charges, so our electric field is going to be in newtons per elementary charge. Now, we need the direction of this electric field. Okay, remember, the electric field is a force exerted on a unit of positive charge. If you put a positive charge there, okay, Q2 is positive. What's it going to do to a positive here? Well, it's going to try and repel it. It's going to push it down. So there is your final answer. All done. All right, you are now ready to tackle your assignment. Oh, I should say one thing. This formula right here, E equals KQ over R squared. This formula is good for point charges. So if you got a big honking fat charge right here and you're trying to figure out the electric field over here at some distance R away from it, well, this formula, okay, the KQ over R squared, it is not going to work because the distance involved is, or pardon me, the distance across the charge is significant compared to this distance. Okay? If all of a sudden you wanted to figure out the electric field of this charge way over here, again, if you're trying to figure out the electric field to this charge way over here, well, now the distance across the charge is insignificant compared to this distance, so it would be considered a point charge, and yeah, you could use this little nugget. That being said, we're always going to make sure when we're using this thing that our charges are point charges. You won't have to worry about a non-point charge situation. All right, now you're ready to do your assignment, which I will post as well. Bye for now.